Well, that's great. And today we have Dr. Bill Bush from Kentucky and come to visit with us. And he's the director of Center for Research in Mathematics and Science Teacher Development. Of course, he's also a professor of math education. And he was actually in Texas before, so he knows about the area. He has a special passion about Texas. So that is a great thing. Okay. And so today we are going to learn something about his work and also the kind of project that he has been doing. And so welcome, Dr. Bush.
Okay. Thank you. Well, let me tell you a little bit about myself. I am a graduate of the University of Kentucky. I have my undergraduate degree and master's degree from University of Kentucky. I have my doctorate from University of Georgia. My first job as a professor was at the University of Houston, Victoria. So I'd spent my whole life in Kentucky, and my first job was just down the road here. I was at UHV for 3 years. Loved it. Nice little campus there on a community college with Victoria Community College, and got all of South Texas covered in terms of doing math ed with the teachers down there, and so enjoyed it. Then University of Kentucky came calling me back. They hired me as a professor there. And that's unusual for them to hire somebody who got a couple degrees from them. They don't usually do that. But they hired me back at University of Kentucky. I spent 17 years at University of Kentucky as a professor. Then I was lured away from the University of Kentucky to the University of Louisville, which I don't know if you know, it's kind of like Texas and A&M with Kentucky and Louisville. They're arch rivals, especially when the round ball's going and basketball's going on. They really don't like each other at all. But I kind of sucked it up after being a Kentucky fan for a lot of years and went to the University of Louisville. Now I'm a Card fan, and I just have to deal with one football game and one basketball game a year. Then I can just pull for both of them throughout the whole way. But so I'm at University of Louisville now. I went to the University of Louisville. They hired me to direct a center for research in math science teacher development. So I'm a full-time administrator. I have a 12-month salary there as an administrator. I haven't taught any classes since I've been at U of L, which I kind of miss a lot. But I basically run projects. And I've had a series of projects, and I'm sharing one with you here that we actually did when I went to the University of Louisville. They, as part of starting this center, they asked me to come in and start this center. They had some federal funds available to get it up and going, and so I chose this particular project as the starting point for how to spend that money. And basically, the DTAMS came out of the U.S. Department of Ed, and it was in 2008. And DTAMS stands for Diagnostic Teacher Assessments in Math and Science. We've done we actually have done 3 batches of DTAMS. We've done DTAMS for elementary teachers, DTAMS for elementary math, DTAMS for elementary or middle school math, and we've done DTAMS for elementary middle school science. I wasn't in charge of the science part of that. A colleague of mine, Tom Treader, did the science DTAMS. I did lead the development of the DTAMS. And at the time, when we were doing this, there really weren't many teacher assessments around. There was the standard stuff like the Praxis and the National Teacher Exam that you do for certification. But no one was really trying to build assessments that really tried to capture what teachers needed to know to do their work. And that was our charge with this particular project. We wanted to give researchers, professional development providers, and instructors tools to assess the breadth and depth of elementary and middle school teacher mathematics knowledge, and then provide prospective teachers, practicing teachers, feedback about their strengths and weaknesses. So it had 2 purposes. One, for instructors or PD providers. In fact, the most common use of these has been through professional development providers. They'll give assessments at the beginning of the professional development, they'll do the professional development, then they'll give it at the end to see if they learned anything as a result of the PD. So that's been the most common use of these. We've had a lot of folks use them in their courses, both in the math courses, say for elementary teachers that you get in the math department, and for methods courses that you get in the College of Education. Folks have given them as pre-post before those to see what is it that teachers are learning as a result of being in those courses or experiences. So that's kind of the way that researchers and instructors have used it. It's also a pretty good diagnostic tool for the teachers themselves. It will let them know what their strengths and weaknesses are, what they know and what they don't know. We've got, over the last couple of years, through the work of Deborah Ball at Michigan and others around the country, there's been a lot more focus on the knowledge that teachers need to do their work. We basically just in mathematics thought, okay, we'll give them a bunch of math courses, we'll give them a bunch of education courses, and then let them go figure out what to do with it after those. And so now we're being more purposeful in saying, you know, there is a professional knowledge base that teachers really need to have that others don't have to do their work. Knowledge about curriculum, knowledge about students, knowledge about assessment. Those are unique kinds of knowledge that people just walking around the streets don't have and don't know. And so we've gotten better through the work at Michigan, Michigan State, some of our work at Louisville about really trying to hone in on what is the knowledge that teachers need. Now, as we know, just because you have the knowledge doesn't always mean you can pull it off, but we do think that if you don't have a basic knowledge, you're going to have trouble pulling it off, and teaching is going to be a struggle for you. So that's what our purpose in developing these assessments were. We developed in mathematics two sets of assessments. We've developed one set for elementary teachers and one set for middle school teachers. Since this project, I've had an NSF grant, and we've actually created geometry assessments for high school teachers. But that's a different project altogether, so I wouldn't just mention that. But we spent most of our work. So we have right now 8 different assessments. 4 for elementary teachers, 4 for middle school teachers. They're each about 30 items, combination of multiple choice and open response. We couldn't figure out ways to write good higher level questions in a multiple choice format, so we put open response in there just because that's what we kind of wanted to capture in this. So those are the 8 different assessments. They're available on the web. You can go to our website, the Center for Research in Math Science Teacher Development. Go to our website. You can get these. The assessments are actually free. You can just download them off the web. You don't have to pay for them or anything like that. However, if you want them scored reliably, validly, we'll charge you for that. So that's the way we decided. Since we got the money up front to build the assessments, we didn't see it didn't make sense to charge for them. So if you want to score them yourselves and do that, that's fine, and they're free to use. But I've got a bunch of trained scorers at U of L that we've trained, and they will score them. And you need the reliable scoring because we have open response questions on the test. So the multiple choice obviously aren't very hard to score, but the open response do provide a bit of a challenge. So what types of knowledge do we assess? The first 3 are mathematics knowledge. And we just stole this from Norm Webb. It's his kind of categorization of knowledge of learning mathematics. Type 1 is rote knowledge, memorization, includes memorizing definitions, memorizing procedures, memorizing rules, and so forth. So there are items on there that see what you've memorized and what you know with that. There aren't many on there, but there are some on there. That's not the item we value those. Type 2 questions focus on understanding, understanding of mathematical concepts, mathematical procedures. That's different than memorizing. It's one thing to memorize the long division algorithm. It's another to understand why that works. Does that make sense? And so the questions focus on both. And of course, a teacher needs to know why it works, not just how it works. So understanding the procedures of mathematics, how to factor, how to do long division, how to solve equations. We test both their ability to do that, the skill to do that, and their understanding of why those skills work. Because there are mathematics rules that dictate and allow you to do that. Type 3, it's problem solving and real world applications, reasoning, We'll have some things, if you remember the old geometry proofs you had, where you're proving things, we have proofs in there. You got those nice verbs of conjecturing, validating, analyzing, justifying. So this is kind of, if you're familiar with Webb, it's type 3 knowledge from Webb's types of knowledge. And then the last one, the type 4 knowledge that we assess, we consider this the unique knowledge that teachers have to have. Knowledge used for teaching, forms of how do you take a mathematical idea and represent it in multiple ways. How do you identify the analogies that help students understand something? What are the illustrations, examples, explanations, and demonstrations? So that's the mathematics knowledge for teaching that really, the only people in the world that are really walking around with that kind of knowledge are teachers, because they've got to be able to understand and know that content at a much deeper level than just the other person. An engineer might even know. And engineers need to know how to perform the procedures and do the work. Teachers need to know why that stuff works and why you can do that and so forth, because that's what they're trying to help you with. So our assessments focus on these 4 types of knowledge. Now let me stop there before we get into the assessments. Are there any questions or comments about this so far? No? Done that good a job, huh? All right. So where do we get the resources to develop the assessments? Well, we started with the curriculum evaluation standards for school mathematics and the principle and standards for school mathematics. That's the NCTM documents. They give a lot of information about what students need to know, so forth. Benchmarks for science literacy from AAAS, we use that document. Foundations for Success from Achieve, we use that. We use information from NAEP, because since NAEP is such a powerful test for teachers, then we use that. We use TAMS information, and then we just read a whole lot of research on student learning and misconceptions. We did a massive, have enough doctoral students around at U of L, we could do some pretty good literature reviews. And so we went out and we did literature reviews on whatever math content we were going to assess for teachers. We got in and we looked at what the literature said about what are the common student misconceptions and errors in that. Because that's what teachers need to know. They need to anticipate that, and they need to be able to deal with that. So we dug heavily into the literature, and we created questions about common student misconceptions and errors, because that's the walking around knowledge that teachers need to be equipped with. Okay? So that's the source for the assessments. Now, what we did was to build the assessments, we formed kind of interdisciplinary teams. The teams included math educators like me and my other colleagues. We brought in mathematicians from math departments. We needed to have that kind of mathematics expertise. They're the ones that teach the math for elementary school teacher courses. They're the ones that will teach the geometry course for high school teacher or middle school teacher, or the numerical analysis courses or whatever. But we needed to have mathematicians at the table because they're deeply involved in knowing the mathematics that teachers need to have. We also made sure we had teachers at the table, and they got a little worried. They were kind of glad, especially the retired teachers, were glad that they were retired and weren't going to have to ever take these tests, because we were putting some teeth in them about the mathematics they needed to know. But they really helped us, particularly with the pedagogical content kind of questions, in terms of knowing what does the teacher need to know about kids mathematically that work. And so they brought that, and then we also brought in some school administrators, principals, and district math supervisors and others. So we tried to get as diverse group as possible to help build the test, because we felt that then it would be more credible to the people who would use the test. If you look at the group who's doing it and you're like one of those, you feel a little better about the product than if we had just a bunch of mathematicians creating it, or just a bunch of professors in education creating it. So we tried to give the test some validity and some credibility, making sure we had all the different players at the table to do that. So we ended up producing kind of 3 types of items. We had multiple choice items, which are your standard multiple choice. That was 1 point each. We had true-false items, 1 point each. And we were really committed, although it causes all kinds of scoring problems, to have open response, extended response questions. And those were longer, 3 point each. And of course, not only are they make the test longer, but they cause you more issues with scoring, because you can't just give them a nice little score sheet and say, okay, here, these are right or wrong. And so what this entails, it means two things. One is we really had to be in charge of scoring them, because we trained the people to score them. If you were to take the test and say you wanted to use them and give them to a bunch of teachers, and then you wanted to score them, well, that would be the hard part for you, scoring the extended response, because you've got to read through them first of all and decide. So we created detailed rubrics, and then I've probably got about 6 or 7 retired math teachers in Louisville that are scorers for this. And so they've been through detailed training on each and every item to make sure that they can use that rubric in a consistent way. But we just decided that extended response questions, despite the extra hassle on the scoring end, add some mathematics knowledge that you just have trouble getting at with a multiple choice or a short answer. So we were just committed. In fact, I guess we were lazy. We didn't want to try to write those extended or short answer, or it's not the short answer, but the multiple choice in a way that got at higher level knowledge. So we just took the easy way out and wrote questions that got at higher level knowledge, and then ended up setting it up so that we trained scorers then to do that. And that was a big challenge. But you know, 2-3 years out now, it's worked for us. I've got a whole group of retired teachers in Louisville who have been trained. We run them through the training. They turn these things around pretty quickly, and they do a good job. And in fact, we've actually assigned them different versions of each test so that they kind of see the same ones over and over again and get that kind of consistency. So, as we were building the assessments, before we made them ready for the world, we did lots of field testing. We had over 300 of the pilot assessments completed by teachers in 38 projects across 17 states. And the way we did this is we just did an email search of who's doing professional development with a group of math teachers at the middle school or elementary level. Would you be willing, as you've gathered them together, to give them this test? And some would be willing to give it once because they were busy with the professional development. Some, they actually wanted to use them as pre-post tests for their professional development. So they give them when they walked in the door of the professional development, and 2 weeks later, after the professional development was over, they gave them as an exit test, a different version. And that's the way we intended it to be used, but it got us more data to be able to do the analysis in terms of whether the items were reliable, valid, and so forth. So this was still all in the field testing, but we got quite a bit of you can see we even had 71 teachers, bless their hearts. They took a pre-test with the assessment, then they took a post-test, then 6 months later they took another post-test to see if it hung around with them. And so you got to give them, I'm sure they were really tired of that test by the time they took it 3 times. And these were different versions of the test. But that's how we did the field testing with actual teachers. Most of these were in Kentucky, although we actually had 17 different states. We just did kind of a national search through the Association of Math Teacher Educators is how we recruited those groups of people. So let me stop there. I'm going to share some items with you. Let me ask you if you have any questions about the assessment itself. I'm going to give you an email or a web address where you can go look at them and see them. They're on the way up, so you can get to look at them if you want. Any questions so far about the assessments themselves?
A question about, so you said that there's a scoring of the open response with the other types of items. So the people that take the test are just assigned a score, I guess, like kind of a whole number score for the overall assessment?
Yes.
Okay.
They get an overall score. We have them divided into skills, conceptual reasoning.
Okay.
They get it broken down that way.
Gotcha.
If it's like a probability statistics, we'll break it down to the probability side and the statistics side. And you know, it depends. If it's number computation, we might break it down whole numbers, fractions, decimals, and so forth. So the results we get, actually what we end up doing is just sending the people who gave the assessment, we give them a spreadsheet with the name of each of the persons that took the test, the score on each item, the total score and another subscore. So they get a spreadsheet with each teacher's score on each item. So they can kind of do with it what they want. They can ask whatever. We didn't want to try to anticipate any research questions or evaluation questions, so we just said, here's the data, do with it what you want. And so we give it to them in a spreadsheet form. Does that make sense? Okay. Any other questions about the test as a whole before we start looking at some items? They've been pretty popular, and I'll tell you, we're actually getting ready to redo them all because the NCTM standards aren't in play anymore. So they've changed the rules on us about what math people need to know. So we're going to have to change our test to capture the new Common Core standards that are now in mathematics. All right, well, so let's look at some items. Here's a algebra multiple choice item. So I'm going to let you look at that, read it, and talk to a neighbor about it. Talk to a neighbor about the solution, what you think and why. Why did you pick that solution? Okay, so what do you think the correct answer is? Somebody? D? C. C. What do you think? Yay or nay? A lot of head nodding going on, okay. That's got to be it then, right, if everybody agrees. Right? Okay, yeah, so what's being assessed here? What are we trying to assess with regard to teacher knowledge?
I think symbolism.
Symbolism, how to use variables. Okay, how to use symbols to represent. Okay, is that important for a teacher to be able to do? Especially if you're teaching algebra, right? All right, so it's clear this is getting at their ability to represent numbers as symbols, right? Variables. So it's getting at the notion of variable. Not the notion of variable in an equation, but the notion of how variables used in an expression, right? Which is a different, right? In an equation, variable becomes the thing you're looking for, right? In an expression, it's not the thing you're looking for, because there's nothing to look for, but it's something that has to represent some particular quantity. Okay? So that's one of the issues that the teacher needs to know, that variables that you see in algebra represent different things. And that's kind of what this is getting at. Represents the variable that's sitting in an expression has different purpose than the variable that sits in an equation, or even the variable that sits in a function, f of x equals 6x plus 3. Those variables are different. They're a relational thing. So in algebra, we use variables in a lot of different ways, and they're used in different ways, and a teacher who doesn't quite pick up on that is going to have a problem teaching that. So we've got quite a few, specifically in the algebra test that we've developed, of really making sure that we have items that help teachers understand that variables have different purposes. That's a pretty fundamental thing about algebra. If you don't have variables down in algebra, you're in trouble, right? Because that's basically what it is. All right. Any questions about this task? All right. Probability.
I have a question.
Okay.
And I don't think it's structured this way, but do you have any two-part questions? Like, here is the math problem, and then follow it up with kind of what you were just talking
Yes.
about. In the above problem, what was the most important concept?
Yes, and then those are our pedagogical, particularly our pedagogical content, and our open response questions. We have quite a few of those. One might be the mathematics piece of it, and then the next question is about the teaching piece of it. I'm trying to think if I've got an example of that in here. But okay, so here's a probability question. This one's pretty basic, right? Okay. Which one? B? Why might somebody think C is the answer? B is the correct. Why might somebody think C is the answer?
They look at part to part.
Parts to parts? Right. What about A? Why might A be an answer?
The total of the green marbles, not the total of all marbles.
Right. There's 1 out of 4, and there's 4 green marbles. All right. What about D?
Choosing 1 out of the 9 marbles.
Okay, rather than 4 out of the 9. So there are some reasons for each of the distractors there. That's one of the challenges in writing multiple choice questions, is you just can't make up any old number to throw in there as a distractor. You have to really try to understand. In fact, that's where our teachers came in real handy, because we'd take this and say, okay, what are the errors that students would make with this? And we talked about those, and then we'd create answers that mimic those errors. Okay, let's look at another one. If you can sit down and do this in one reading, I'm impressed. Okay. So this is an open response. Talk to a neighbor about this one a bit. Share your thinking about this. Okay, talk to me about this one.
That's what I was about to say.
What is the height of Mr. Tall and paper clips? That's the first part. What did you decide? I'm seeing a lot of confidence in this one. What do you think? 10 and a half? 10 and a half? Now people are more confident. Yeah. Okay. Okay, so 10 and a half. So how did you think through that? What did you do?
I set up a proportion
Okay.
and then cross multiply and divide.
So you set up a proportion, cross multiply and divide. Anybody do it without setting up a proportion? Okay, how did you do it?
I set 2B equal to 3P. I solved for B, and then I substituted that in for the B instead of B.
Okay, so you set up equation and then
Solve.
2 equations, 2 unknowns.
Mm-hmm.
Okay? Any other ways you do this?
I drew a model.
You do a model,
I drew a picture.
a picture, and that helps you. So you didn't do any of that stuff. You just look at it and boom, picture said that's it. Okay? Excellent. What else? Any other strategies? So what's being assessed here? What's being assessed?
Being able to substitute variables.
Okay? Have you heard of proportional reasoning? And actually, proportional reasoning means you can use variables to do this, but also means you don't have to, right? It's a way of thinking through it, and some of you did that. So this is hitting right on the head of proportional reasoning, which is a critical middle school skill to develop. And we actually know for middle schoolers, it's developmental, that some kids, you could just put a gun to their head and they couldn't do it because they're just not developmentally ready to think. Because I mean, if you think about a person who just did it in their heads, that's pretty strong proportional reasoning. Having writing the proportions is a good strategy to do it and to get you the right answer as well. But this is kind of, a person could do this if they didn't think about whether there were proportions involved or not, just by thinking through it. But
And isn't there the problem that we run into that I see with students with proportions is because of the cross multiplication, they really do not understand what they're doing. They cross multiply.
That's a rule.
just
That's
it.
a rule, right.
And then when they see fractions, 2 fractions being used in other contexts, then they cross multiply
I've seen like
they should.
2/3 divided by 1/16, and they just cross multiply because they're sitting there together like that,
Exactly.
right?
Because they don't get that.
Because that's the rule.
This is a representational, but then also that proportional relationship that's going on.
And what we found, and obviously teachers need to have proportional reasoning, especially if they're teaching proportional thinking. But proportional reasoning is a critical thing for success in algebra. It's kind of a number success for algebra, that if kids who don't have proportional reasoning really struggle with solving equations, they're the ones who end up kind of rotely solving equations that have no meaning to it. That's the same reason they do the proportions.
I just wanted to add to that, it's also really important for the sciences.
Yes, absolutely.
Concentration, osmosis, density, all of that is
Yes,
proportional.
absolutely. There's a lot of proportional reasoning in the sciences, particularly chemistry and physics. There's tons of proportional reasoning there. So, these are critical things. And so, you know, we've got quite a few items like this across the assessments because a teacher just has to be able to have proportional reasoning. They just got to be able to think proportionally. And, you know, again, you find it's no fault of their own. They just didn't quite get the kind of instruction they needed.
So this, I assume, is an open response item
Yes.
to explain. So if they solve it without using proportional reasoning, by substituting like I did,
Yes.
would you then say they don't have a understanding of proportional reasoning when there's different ways of solving the same problem?
Well, the key to that is to justify your solution. So if there's 2 ways to justify the solution, by using words or using equations. So if they used either one, we gave it to them.
Well, I mean, you gave them credit for it being correct.
Right.
But in your rubric, for evaluating?
They got 1 point for being correct,
Uh-huh.
and 1 point for, or 2 points for being able to justify.
So it doesn't matter how they justified it, whether they used
Well,
the
using a
imagery,
correct
formula,
using a correct justification. I mean, there's multiple correct justifications, there's not only one. So as long as they, first of all, they got the right number, and then secondly, they had to provide a correct justification. And there are multiple ways. I mean, one is doing the proportion, one's drawing a picture. I mean, they may have drawn a picture that showed the relationship, and that's how they got it. We took that as, you know, if they showed they had some sort of they either had to justify the thing numerically it was correct, or had to use proportional reasoning, explain it using proportional reasoning.
Well, I think too that's where the measure of mathematics knowledge for teaching is so critical, because the way that I would teach that to, say, a 5th or 6th grade child, and the way that I would teach that, or what I would expect from an 8th grade child or a 9th grader in Algebra 1 is so, so different.
Right.
It would be completely inappropriate. I mean, proportionality, to set that up as a proportion, cross multiply and divide and solve it, we so, kind of like you were saying, we so often in the classroom rush to procedure
Computation
without
and procedure,
understanding. So I might understand it, my math content knowledge might be great enough to whip that out real quick in an equation, but if I were to teach that to a child in the same way, that would not be appropriate.
Right.
And some kids are going to take that and they'll go, all right, 2 buttons equals 3p, that 2 to 3 relationship, and then they will go, okay, 4 would be 6, and then they'll keep multiplying by things. And what they'll do is, and I see them do this, is they'll get it down between the relationship between 12 paper clips and 9 paper clips, because that will give them 6 buttons and 8 buttons, and then they'll say, okay, I'm 3 here and I'm 2 here and I need to be 1. Okay, I split that difference.
Right.
And then that is when you really start to see kids understand.
Right.
Is when they're able.
But then
to
you also
begin
see them
to-
start adding numbers instead of
Right.
And that's where the proportion, the proportion reason is down to 2, so they really.
Yeah.
And we've got a pretty good amount of research out there that proportional reasoning is developmental. That it's not just having the mathematics knowledge on the front end of it. It's really being able to think proportionally. That's a hard. I mean, it's like it's a Piagetian kind of a thing that they're just not developmentally ready for that, and that's why we see this proportional reasoning usually doesn't show up until later middle school algebra because kids just aren't quite ready for proportion. Now that doesn't mean younger kids can't do it if they, you never know, but it is a huge issue, and it's a huge issue because there's tons of problems out there that require this thinking. I mean, a lot of everyday problems deal with that. Okay. Any other comments or questions about this one? Yes.
It's not so much about the question, but when you have justify your solution, do you explain to the students beforehand what your expectations are to what you mean by justify?
No.
No. So you just.
I mean, it's an item on a test.
Okay.
So that it's. I mean, we would hope somewhere somebody in their life explain to them what justify. I mean, that's what we're testing too. Do they know what justify means?
Okay.
If it's just plugging a number in and say I just justified it. No. So part of this is assessing their knowing what justifying a solution is or validating that the solution is correct. That's what's being assessed. Okay. Anything else here with that one? This one always gets a little. And these are actually there's been a lot of research done on these kinds of tasks. There's people that spent their whole lives doing research around this proportional reasoning and these kinds of tasks, getting kids at different age levels to do this. Obviously, Car Plus Enrollment have done some of that, right? So, because we took this from them. All right, how about this one? You might want to get a partner for this one.
So 1 million divided by 4. So what was 1 million divided by 4? So then divide that by 5. What's 2,380.9? So it's 0.19. So 0.9. So X is 5 times
So you like this one?
No, it's hard.
It's just arithmetic.
But
Right.
they wanna grab their calculators, right?
Yeah, this would be a good for a calculator, wouldn't it?
No, it's not necessary. Some of these know me.
Actually, I don't think it'll fit on the screen anyway.
You'd have some difficulty.
Okay, so talk to me about this problem. Is this fair game for a middle school teacher to know how to do? So what's getting assessed here?
problem solving?
Problem solving,
Actually, conversion too, conversion of units,
conversion of units.
because you have to get down,
How about working with big numbers?
definitely.
Definitely big numbers. So what do you think about this problem?
I like it.
You certainly find out who knows how to kind of think through the big number stuff, right?
Mhm.
Yeah. So it's fair game for a teacher to know, middle school teacher to know? I've gotten some complaints in the past on this one, mainly on the length, right? Because although the more you think, you can usually kind of cut some of the length out. But
That's right.
yeah, you kind of think about it. So, okay. Any comments about this one? Any other comments? Okay. Should be that. We'll do this one and then we'll kind of shut it down. This one's a little bit different as well.
You're not going to tell us the right answer?
Hmm?
You're not going to tell us the right
I
answer?
have no idea. I just do the talks. I don't want the problems. I don't. I mean, I've got it on a key somewhere back in the office, but, so.
Oh,
It's gonna make us crazy.
I'll tell you what, email me. You're going to have my email address. Email me your answers, and then I'll email you back. That's the advantage of being ahead of projects like this. You don't really have to
I
do
should
the
put
answers.
down your steps.
You have to create the
Well,
pain.
maybe the assessor needs to be assessed
At
then.
least we already took it.
Not-
I know, that's what I'm saying. I'm in great
Yeah.
with them. That's all I can do.
I have worked it before, but it's been a while. So let's talk through this one. Let's see people kind of, some staring. What's first step here? What do we do? Well, we got to rewrite that a plus b squared, don't we? Into
A plus B times A plus
a plus b times a plus b, right?
Yeah.
All right. Then first step,
A times A.
A times A, right? And then A times B,
A times B again.
and A times B again, and then,
B times B.
okay? So what are the properties that allow you to do those?
Distributed?
Right, they're distributed property, right?
Yes.
You're basically taking this and distributing to that, and then doing that to that, right? So there's quite a few, there's 4 distributed properties there, right? So then what?
You're gonna have to use associative property in there because you have an AB and a BA.
So you got an AB and a BA, so you gotta know that those, actually community says that those turn around, right? So you got that property going on. All right,
And you're gonna have to use identity because you have AB and AB, which is 1 times AB plus 1
you
times.
gotta know there's a 1 in front of that, so there's identity property there, right? There's 1 of them. And then you've got basically the like terms. And you got A on the back. Now, is this important for students to know?
Very.
How about teachers?
Absolutely.
Teachers, yes. Students, you know, I'd take it if they just get the FOIL, right? You know,
Okay.
FOIL. Well, first out or last. Go, move on.
Yeah, we don't want that
No.
one, but anyway.
But
You can do it with the
But it
drawing.
justifies the FOIL method. Basically, that's what this is. It's justifying the FOIL method in terms of why those problems. And it's really just a lot of the distributed property over and over, and then you got to do some things to combine it.
Well, isn't this I mean, I know this is in the NCTM standards, but isn't it in Common Core as well, to knowledge of the properties?
Right.
Because I know in the math text,
Right.
currently, it is not, but in the revised version, which
Right.
is supposed to roll out next
Heavier,
fall,
much
properties
heavier
are back.
much heavier emphasis in the core on why you're doing algebraic
Yeah.
steps instead of just doing it.
And pretty early.
Right. I mean, yeah,
5, 6.
I mean, community and social distributive usually show up fairly, community certainly shows up really early in the
Yeah.
curriculum. Distributed a little bit later. Associative means you got 3 things, it doesn't matter which 2 you do first. That's what associate says. So then the distributive is one that starts, kind of hits at algebra. But yeah.
And if kids learn the distributive property for those type of things, they will not forget the formulas.
Right.
Because what teachers sometimes do is they teach, okay, whenever you have something squared, you have a binomial squared, it's gonna be square the first with the product of the 2,
Right.
double square the last, and kids don't,
No.
it's words.
A squared
But
plus B
if
squared.
you show them distributive property twice, if you show them that's what it means, then they will not forget.
And even taking this and putting it under that and then doing the multiplication out that way like you do with whole numbers is a good way to help them understand that it's really just like you're doing the same thing you're doing with whole numbers. It's just they're sideways instead of up and down. But
And algebra tiles are awesome.
yeah, they are, you're right. That little area thing pops out nice and pretty, doesn't it?
Yes. And then, because if they've been taught from the get-go about writing multiplication as arrays,
Yeah.
and when that transfers into that area, and then when you get to this kind of thing, then it all just kind of fits together.
Yeah.
But it's a process.
Right. Okay, we're not gonna do this, so I'm just gonna show you, here's another pedagogical content. Explain or demonstrate one way to help students understand why 2/5 divided by 1/4 equal 1 3/5. Not that it does, but why it does. So you having to give a step-by-step justification for
I'm so
why do you
excited.
invert, why do you invert, why do you multiply,
It's not
why do you multiply across the top, across the bottom, all those things. And that's stuff that teachers got to know. Actually, students should know too, but teachers got to know. And so, if you wanna get a copy of DTAMS or see some, all you gotta do is Google CRMSTD. Google that. It'll send you to our website. If you want to order them, you can contact my staff assistant Patty Grimes or email me at bill.bush@louisville.edu or pgrimes@louisville. We can send you the assessments, and that's pretty much it. Where we are with this, and this is just the last hurrah, we've just gotten a $1.7 million grant from IES to redo the middle DTAMS. That you've seen the old one. They were based on NCTM standards and problem solving and reasoning. Those were the two higher level things we did. Now we've gotten a grant from IES to align it with the new core standards. So some of the mathematics has moved around. So we have to change the items because the math is different. And the notion of what it means to do math with the 8 mathematical practices. So those upper level kinds of questions are now broader, where we had problem solving reasoning before, and there's now attentive precision, the whole set of practices. So it's broadened the kinds of higher level activity we're trying to capture with the assessments too. We just started this in October, and we're in the process. In fact, we had a meeting yesterday with our group that's working on this now, and so we've got a batch of teachers and mathematicians and math educators who are writing items as we speak to deal with this new. And then we've got another proposal in to do the same thing with our elementary DTAMS. What you saw today is the middle school DTAMS. Items from that. The elementary is similar structure, same idea, but we've got a proposal in to do that, and it's currently under review. And that's it. Any questions you have about the assessments?
If I wanted to go and take the assessment and have it scored, do you know how much it would cost me to have it scored?
$3.
Oh.
Something like that. I mean, it's cheap. You know.
That's a good deal.
I mean, I think the cost is $2 per assessment now. I'd have to look it up. It's inflation has pushed this up a little bit, but I'm having to pay my scores a little more now to do this too.
So can you do that as an individual, or do you have to kind of be a part of a PD group
I mean,
or some kind of
yeah, I mean, you know, you could probably just do it on your own and sit down with somebody and score it, or you know, you wouldn't need to send it to us. I mean, what we do is we do the official. I mean, I've got trained scorers who do it because these folks do it as part of the evaluation of their project. So they've got to have good concrete numbers and a rationale for that. So that's why I have trained scorers doing it. If you want to just sit down and take it and sit down with a bunch of friends one night with some pizza and beer and just talk about them, and, you know, you can do that. Make sure there's some good math people in the room. But you know, I mean, they're free to use. The only thing we charge for is the scoring.
Well, I mean, I think it would be, as a prospective teacher, a good thing to even just put on, like, A, to assess yourself and to see if you're really ready to do this, and B, to put on your resume as, you know, look, I scored really well on this assessment. Just an extra thing.
Anybody out there knew what it meant. That's a whole other issue.
And you have scores for the science tests as well?
Yeah, same thing. The science is set up the same exact way. So you can just go to our website, and they're all on there and available to you. Like I said, the tests are free for use. We charge for the scoring. That's it, because I've got to pay people to do that, and we have to train them to do it reliably and with validity. Okay. Anything else?
Well, thank you very much.
Well, thank you.
I'm sorry I came in a little late.
Appreciate you coming in.
Well, now we're going to, I don't know, is the next thing at 12:45, 11:45 or 11:30? I don't remember. But I'll get you where you're supposed to be. I have orders. I'm to get you where you're supposed to be.
Well, I'm
appreciate all of you coming.
supposed to be talking to students in the next thing. I think I've just done that.
I think you have. I do recognize a few of these people, so. This one I have right now, so.
And we're not studying.
No, but that's a former one. Well, worked with her, okay. But really do appreciate it, and this, I'm telling you, this is some good stuff, okay? This really
That's
is.
really
This is,
interesting.
this is
We've thought about
what
it
we
a lot.
want.
We've really put a lot of thought into this.
It is so, it is cutting to the heart of what we as teachers need to understand when we teach mathematics. It is not about procedure only. It is about that understanding.
And as someone who's
and-
recently
and
out
the
of the
problem
middle school
solving
classroom,
yeah.
don't let anybody convince you otherwise. I know Dr. Goldsby tells you that all the time, but you will go into schools and you will work with a teacher who's been teaching for 16,000 years and will tell you, oh, it's okay, baby, just teach them how to cross multiply and divide. It doesn't matter. They are wrong.
Well,
It won't be just
It
the
matters.
old fogies.
The new curriculum materials are coming out, and they're based on the new core content, and they've got the practices all over them, and so, you know, they're getting ready to ratchet up the math that's, and if you look at core content versus the old NCTM standards, they've pushed some stuff down. There's some stuff that's moved down to earlier grades.
Yeah,
because
that's
they
true of the
decided-
text as well.
Yeah.
Way
So,
down.
But if people learn mathematics the correct way, if you learn why and not just how, teaching it is so much easier, plus it's so much more engaging for you as a teacher. It's awesome when you really start to
Sometimes
understand
fun.
instead of fear.
Yeah. Will you go with me with the next talk? Can we go to
Wow, I'm
let's,
giving a
let's
fun
go to
hour.
it. Let's take this on the road.
Oh, yeah, no, I mean, I'm serious. This is, and this one, they hear me sometimes. Of course, this one was, I was
I'll
on
preach
her
it, I'm
committee.
telling you. And you'll get back in the classroom. I got my master's, I went back into the classroom, and you'll fight the same battle. But it does not mean you're wrong. It just means there's a greater battle to fight. And when you feel like an island, just call Dr. Goldsby, and she'll like
That's right.
fortify you and carry on.
And I mean, it's hard to, and it's not just ones who've been teaching a long time. Sometimes it's amazing how those that are going through the process will not listen and open their minds to, you know, hey, there's a better way.
It's what's best for kids. I mean, that's what it
Oh, yeah, it is. But I'm telling you, do it, and you will. It's just better.
That's
This is my rally. This is my thing. I'm sorry.
Like I said,
Poor man.